Welcome to the last session of the week for us. Hopefully everybody can see my screen okay. Just let me know if that's okay, Damien, or okay?
Yep, that's fine.
Okay, mate.
Fine.
Yep, okay. So we'll crack on. So like I say, so today's session, we're going to talk about our real-time locating business. So anyone that was with me and Fergus yesterday, you would have gone through our industrial identification portfolio, our OID camera business and our RFID business. This is a new addition to the ident portfolio. We acquired a company about just over 18 months ago now to give us our location business. So I'll let Fergus, so I'm here again today with Fergus. Fergus, say hi and introduce yourself and we'll get cracking.
Hi there, cheers Lee. I'm Fergus Sykes, automation specialist for SIMATIC ident. So I sit within technical support, normally based in Manchester, but obviously home based at the moment, coming to you over the internet.
Cheers, Fergus. So what we want to do this afternoon is introduce you to our RTLS business, talk to you about the portfolio that we have. We're going to show you a quick demonstration on our locating manager and our visualization intelligence monitoring. We're going to talk about some use cases, which is really important in RTLS, of where RTLS can obviously benefit customers and what we see in the digital factory today, where Fergus will help me with some technical basics of how RFID works. And then we'll talk about some how we take RTLS forward when we try and deliver a project to a customer, and then we'll take some Q&As at the end. So, like we say, where we were yesterday, our SIMATIC ident portfolio, our OID business tells us what the asset is by reading a barcode. We have our RFID portfolio that can tell us when the asset was detected. But what RTLS now gives us is a third bubble, and now we can obviously look at where is the asset. So RTLS is real-time location system, and it enables us to locate assets, objects, down to quite small centimetres. So if we take the lid off a digital factory and we have a look inside, where could we possibly use RTLS? Sort of applications. So number one here, where we could find, so if we're actually particularly looking to locate an asset, we can actually locate the asset down to 30 centimeters. Okay, so fine. We have number two is our document process. Because we have sort of electronic transponders, we can electronically document a process, thus removing paper from the shop floor, so plants can look at going paperless. Three, we can monitor what's going on in terms of production, so we can get information back from machines, the state of machines, whether there's any faults on the machines, so we can get information back and monitor what's going on. Four, we can control our production, so we can control our tools on our production line. We may want to control our torque tools for activating and deactivating torque tools. And number five, guide, so we can guide operators, people, we can guide AGVs, we can guide what we want through a digital factory and tell them where we need them to go and where we need them to be. So the five applications that we can do with RTLS, we have three, if you like, levels. So we start at the bottom with our hardware infrastructure. So then people who were with me yesterday were talked about RFID and it being passive base. Obviously RTLS becomes active for us, so we have batteries within our intelligent transponders. Our next level of hardware, we have gateways and anchors that are positioned around a warehouse that gets the signal from the transponder back to the gateway, and then we pass those X, Y, Z coordinates back to our locating manager software that sits on the customer's server. This then can execute and send to any sort of business system, whether it be SAP or any sort of ERP system that the customer may want to get location data from. That's the sort of three elements of our RTLS system. So dive a little bit more deeper into the darker grey colour is what we do as Siemens. So we provide hardware, both anchors and gateways, like we've said, to different sorts of transponders. And we also have this locating manager software that sits on a customer's server to manage what's going on from the data from the field. And then obviously then we can export that data into any sort of business application the customer may have. Like I say, would it be an SQL database or whatever sort of business system they would like to get the data from. So the darker grey is what we do, and the sort of lighter colour is what would already be currently there from a customer's architecture. So we're the first major automotive provider to scale locating systems in the industrial arena, as I call it. So SIMATIC RTLS is the first industrial RTLS system on the market today. And we can get down to precise locating axes, like I said, 12 inches, maybe 30 centimeters, based on our ultra-wideband technology that we use. RTLS is very scalable infrastructure. So what we talk about is we can start very, very small. We can take a little area, a little stores area maybe for a client, get them used to using RTLS, get to use the business case of the ROI of how RTLS can benefit their business, and then we can upscale quite easily. So we can add more transponders, we can add more gateways to cover a larger area. So you can start small and work the way up. So it's very scalable. And we've got some hybrid technologies which allows our technology to be used both indoors in the factory and also outdoors, using the same hardware in terms of the gateways that we use. So it's an indoor and outdoor system, and we can obviously optimize coordinates in terms of value add. So not only can we get the XY, we can also get the height. We can get the height as well. So things. So a little slide that HQ put together for me. So our motto with RTLS is we put your company in motion. Just pick up a couple of things here. So RTLS has teamed up with our SFS team, our sort of financial partners within Siemens. So it allows us to look at projects that may not necessarily need to use the CapEx budget. We can go down an OpEx route, and we have some flexible leasing options available from our SFS team to allow this to go on a monthly rental base. Like I say, we have flexible and scalable, like I said before, that you can start small and move up. Some best performance. We have, like I say, quite tight accuracy in demanded in industrial level. So 30 centimeters is quite a small, tight accuracy. And we have obviously the comprehensive solutions. So we have a global network of solution partners and project teams around the world. So we have RTLS hubs in some regions that obviously have the expertise to support with any RTLS project. So let's have a dive down into what the portfolio looks like now. So obviously we have transponders. Like we say, so we have a multitude of transponders, and we'll go through some of the different ones in a second. But these transponders are typically what gets attached to a workpiece, maybe a robot, plastic totes, pallets, whatever asset that we want to locate. We have our gateways, which is all sort of PoE now. So when we install these gateways, there's no need to actually run power, up in the ceiling or in the gantries of a production area. We literally just need to run a network cable, and that will suffice us to obviously power these gateways. This is our 2D map of our location manager. So this sits, like I say, on a customer's server, and this allows you to see the transponders move around. So you can see the state of the transponders, where they are in a particular area, and you can click on one of the dots and it will bring up information on that transponder to tell you what the state of it is. But when we go into the demo, that you'll see that a little bit better. And also, which is brand new this week, we have just released our location intelligence, which is our middleware software. So sometimes locating manager is enough for a client. But sometimes people have asked this for some middleware, some sort of API that they can use on a tablet. They can see very easily their sort of bottlenecks within the factory to see sort of tags grouped together. Maybe they want to click on that to see how long in particular a transponder's been stationary for. Why has it been at operation 2 for 30 minutes longer than it should have been? So it allows people from their desktop or from their sort of mobile device to drill down and have a look at maybe bottlenecks within a production environment. So some of the transponders that we have, so we have our 4030T, which is our entry-level transponder. So this is an exchangeable battery that you can change the battery. So this would go on sort of pallets, trucks. So this is our entry-level for ASIC one. Then we move up to our 4060T, which is our CAN bus one. So this is what we use for sort of public transportation. So this could be used in bus or train, or sort of public transport, trams. So this doesn't need a battery. This pulls its power from the actual train itself, and this connects, if you like, to the fleet management system. So this gives us a connection which will allow us to see how much fuel's in the bus, what the mileage is in that particular vehicle. So there's lots of information we can get connected up to the bus system. Then we have our 4083T, which is unique to Siemens and unique to RTLS at the moment, where I still believe we're the only company that have a sort of an e-paper display. So we can obviously display instructions on there for an operator. We can display barcodes, instructions of what we want to do. You can actually change the screen to anything that you want. So from the locating manager software, you can actually encrypt what you want on that 3-inch screen. It has it could be like barcodes, like I said before, it can be serial numbers, and you'll see one of the transponders in action in a little video in a second to see how that works. We also produce like an OEM transponder, so we can produce the transponder in PCB format without any sort of casing. And predominantly this would go into one of our OEM customers that we have. So maybe it be a Clico or an Atlas Copco torque tool, or whether it be a sort of hard helmet, for a particular application for lone people working or something in a mine sort of area. So we can provide it in an OEM format that can be used with some of our solution partners. So our e-paper display that we touched on a little while ago, yes, so that the main use is removing paper from the shop floor. So we have lots of requirements from customers that want to go paperless. And one of our sort of automotive manufacturers in Mexico, particularly, their drive was to be the first paperless automotive factory in the world. And obviously, they needed the e-paper 3 to help them do that. Like I say, it's quite flexible. You can see the status in real time of actually what's happening with the particular asset, and you can also interact with the process or a person by the button. There's a little F1 button on there which allows you to scroll through different screens. So if there's a manual or something that you might need to use, or some instructions on how to use a machine, literally the operator can be at the machine, press the F1 button, and he can see the live information to tell him, okay, this is how to use the machine, this is what button to press, etc. So you can guide employees quite nicely from there. So our RTS locating managers is like a 2D map, if you like, of a warehouse, and within here you can see the transponders. And you can see, the history of them, of where they've been moving, and you can click on one and get some information from them. Like I say, we'll show you that in a quick video in a minute of how that works. How the locating manager software works is based on how many transponders a customer requires. So we have a license for 10 transponder system, 100 transponder system, 1,000, and so on and so forth. So this is just the software. This is just a Microsoft Windows compatible software that literally can run on any computer in the background. Like I say, this is what we released this week. So we have a few customers that asked us for some middleware. So we've produced a location intelligence, which is our API, if you like, that we can run on a tablet or can run on a smartphone device. And this gives you a much nicer view of the plan of your facility. And again, you can optimize the process with this software. If there's any material that's missing, you get basically real-time data to visualize on your mobile device. And again, has simple integration that works with existing ERP systems for the customer. So what we'll do now, we'll quickly show the video of the location manager and the location intelligence. We'll get this to work. Just let me know, Fergus, if it doesn't, there's no volume or something, but you see that, Fergus, on the screen okay?
Yeah, we can see that. Yeah.
Let me see if you get any volume.
This is our standard RTLS interface. This is part of the software that comes with our system. As you can see, it gives you a visual representation of where all your assets are in real time. One thing you will see is that some of these tags appear to be light green, others are dark green. The light green indicates tags that are in sleep mode. As we mentioned earlier, each tag has an accelerometer, pressure sensor, temperature sensor, a lot of intelligence. These light green tags, the accelerometer has detected that this tag has not moved. So therefore, we put it into a sleep state. And in this sleep state, it means that the tag will only blink to a pre-configured blink cycle. So for instance, I think what we typically do is say when the tag goes to sleep, we only need its location once a minute or once every 10 minutes. Whereas when a tag is actually moving and active, we can get update cycles anywhere from, once every 250 milliseconds to, whatever else may be needed. You can also visually see on the left-hand side whenever a tag is in sleep mode, because it will be just dark or black, whereas whenever it's actively moving, it's a light green. So this interface is really just the standard basic interface that some customers are happy with. It gives you just the basic information of where your asset is in real time. And this works for some customers. Other customers need much more information to come out of their system. That's where we've worked with our CS group for a factory that we have an RTLS system installed with the Siemens in Fürth. And what they have developed is our middleware that we call Location Intelligence. Location Intelligence is dashboard-based that gives us a lot of functionality and a place to look at the analytics of where our assets are. So for instance, these individual tags, if I click on each one individually, you will see that this pie chart changes and reflects where each one of these tags is spending majority of its time. I've taken the area that we looked at earlier and geofenced it into 5 or 6 different areas. And now through these analytics, it at one click tells me exactly where these assets are. Also have a tag usage, which tells me how many tags I have assigned or unassigned. And in the future, this can be updated to include battery life, et cetera, et cetera. It also has a page where we can create custom orders. So for instance, I created one for forklifts. Now forklifts, I can put the product number, the number of products available, and the next shipping station. I've already assigned all of the free tags, so pay no attention to this. These are my 3 tags. These are the battery life of the tags, and you can see one of them is low, and the other 2 are at a normal level. What I can do then is go into our visualization map, and here you can see the individual geofences that we've created. You can also see all of the individual areas for each one. And these can be turned on and off. But so for instance, I'm going to look for forklifts. Now I'm going to see where all 3 of my forklifts are located in my facility at one time. I can also click on each individual one and get the individual information of each asset as well. When it comes to the geofences, I can manage each one of these geofences even after they've been created. So if I take shipping, for instance, and I want to change where this area is, it's simply just a matter of picking it up in the real world and moving it or reshaping it as needed. When I make these changes, simply hit save. I go back to my dashboard, and all of this information updates in real time. So again, this application is made to be much more intuitive and a place where you can visually see the data that's being generated from our RTLS server. One thing to keep in mind as well with this is this basically provides us with an API that allows our solution partners or our end customers to put their hooks into our software. If a customer wants custom notifications, say for instance, the notifications column, this shows all of our notifications that the system encounters. So when tags enter or leave an area, if the software goes down, if a gateway loses power, et cetera, we would get a notification here. These notifications are color-coded and have different icons. So if we were to find As you can see, these are all in and out for all of the individual asset tags. If we were to have issues with the network, you would see a different style of notification and a different color. So for instance, if a customer wanted to know if a transponder spends more than 20 minutes in assembly area 2, your solutions partner or customer could take this logic and have this flash or send out an alert or send an email to let them know that somebody needs to go check on this, or if a gateway were down, the same kind of thing. So again, just in general, this is our basic visualization client, and then where all that information is taken and put into some type of data analytics is our location intelligence. This is our standard RTLS interface.
There we go. So go back to, hopefully you can still hear me okay. So yes, that was, so I have to say thank you to Mike, one of our pre-sales gurus, for doing that for me yesterday. So that's a demonstration, if you like, of the locating manager and our intelligent location. So what we want to do now is talk about some particular use cases in RTLS, because with RTLS, there's some use cases that actually are made for an RTLS solution, and there's some cases that may not be fit for RTLS. So there's the three things that we sort of concentrate on when it comes to applications. So if you saw the slides from before, anything for a smart manufacturing, whether it be in the production area or the logistics area for sort of tracking totes, pallets, forklifts, AGVs is a good sort of use case for SIMATIC RTLS. Also people tracking. People talk to us about service and maintenance, access control, lone people working, sort of thing. And the one that we've been sort of inundated with in the last week or so is people are asking us, what can we do about social distancing? Can we use RTLS for COVID-19? Can we give keep the 2 meters distance between the people? Can we alarm when people encroach onto those 2 meters? Can we see who they've been in contact with for a period of time in case an employee gets sick? So yeah, there's a possibility that RTLS could be used for social distancing when people come back to work. And obviously we have our vehicle tracking, our public transport with our CAN bus, have our fleet management, and again access control for using RTLS in an outdoor environment. So here's an application in Germany on a car production line. And again, the car moves down particular stations. So what we see here is what we call an RTLS WIP application, a work in progress application. So what would happen, the car would trundle down the line, and at the end of the line, if there was something missing or something where the car, wasn't available to be finished, that car then would go and be parked in a car park for a period of time until then they can complete that car. Obviously, if there's a particular car they want to pull out, it takes time. It takes them a long time to find where the vehicle is. They're not quite sure. So with RTLS, it allows them to find the actual vehicle that they're working on and actually get it through the system a lot quicker. Obviously, electronically, it will document the process that the guys need to do. Like I say, there's intelligent process control in there. So within a car, there's quite a lot of a wad of paperwork with things that have to be stamped. So RTLS is a very good application for what I call car dolly tracking. So tool release. So again, I think we mentioned about our OEM product. So here is a tool with geofencing. When it may be that there's a procedure to tightening wheels up on a car, it may be they have to start with the passenger front. When the operator is physically in the correct geofence, then we can activate this tool. So we can activate this tool to turn on. We can also get the tool to torque the screws up to the correct tightness, and we can record that information electronically. And then again, he can move to the rear of the car, and again, as soon as the operator gets in the correct position, in the correct zone, again, we can then enable the tool to be used and not used. Here's an application that should run. So here is a prime example of a sort of tote bin tracking. So here that you'll see the transponder. So it'll run a couple of times, so it'll change. I have an Etch-a-Sketch sort of in my mind, show my age a little bit now, how an Etch-a-Sketch works. So you'll see So the display, so what happens now, the lady is walking in zone A with a tote, and you will see that it says in transport on a e-paper display, because the motion sensor is triggered in zone A. She puts the box down into zone B, which is the stores. It's now static, and you'll see now that it changes to in storage. So straight away, people have real-time information on the tag. So anybody that's working with just in time, parts just in time line side, then RTLS is a good user for getting parts to the line, which I call just in time without needing for delays and things like that. So again, enables sort of location-based searching, and if items get lost in a warehouse, you can actually find the actual tote or box or pallet or whatever it may be that you'll know. So you know where that particular box is down to 30 centimeters, so you'll know whether to go to the left box or the right box, in terms of its location. And again, with an AGV application, if we have a machine here that goes faulty in this zone, what we can do is we can replot this AGV's route, so we can make sure that the nearest AGV to the breakdown actually comes to the breakdown and obviously has the right parts on the AGV to fix the machine. So there's a quite an application for what we call route optimization and planning the routes through using AGVs. Here's a sort of a power sort of paint plant, where what we have here is an operator could be working on the sort of cherry picker at the top, but we may not want to have the lighting on down here. We might not to turn the fans on. So again, we could be working in a particular area in this paint booth where we might not need. We can turn the fans off in this area, which will reduce energy costs, because there's no need to have the whole thing extracted when we're only working in a particular small area. Here's an application for outbound for us. You'll see the gateway here. So you'll see outside, you'll see lots of sort of posts that will have sort of security lights on, etc. The gateway will sit on here with a network connection. And this is an application for buses, like we said before. So this is like a depot. This particular application was they wanted to know, sort of the orientation of their buses, because advertisement. So this bus was particularly going to be advertising the Super Bowl the same morning, and what happened is they wanted to have these buses at the front. So the first two buses out on the morning were obviously doing the advertisement for the Super Bowl. They didn't want them sort of parked, and all blocked in by other buses. And again, we said before, we can eliminate time-consuming searches if you're looking for a particular bus. Again, we have electronic documentation of arrival and departure times, and obviously we can monitor the availability of the fleet. So if a particular bus needs a service or it needs refueling, we have that information in real time, so the customer can do something about it. So here's the application that Mike talked about in Firth. So this is one of our sort of manufacturing plants in Firth, and when we did some work with some ROI with them, we found that they took nearly 4,000 hours, nearly 4,000 hours a year, just searching for these ESD boxes. So we quite quickly, very quickly, we could save them more than 170,000 euros, and that's just search time alone. Because what happens, our challenge in Firth is we have a mix of low volume production, sort of low volume, high mix production. So these boxes that contain the parts in ESD are very critical that we get them to line side at the right time with the right material at the time that we need it. And all this was done quite manually before. So this helps us to obviously reduce some of the manual labour. And again, the benefits that we saw from that was literally the elimination of the search times, optimized AGV control. We had full real-time view of the entire material flow, and also we could have digital twin of the production process. A site in the UK that we use for customers that are interested in RTLS, that want to actually see RTLS for themselves, have a play with the system. We have our materials additive manufacturing site, which again, where we do sort of low volume production. But what we do there, we have to transmit quite large tubs of powder around, which are quite expensive, and we need to make sure that the right powder is delivered to the right hopper that goes into the right machine to do our sort of 3D additive manufacturing. So again, the sort of benefits that we see here was the integration that we had with our ERP system. The e-paper transponder allowed us to sort of have the interaction between the employees and the IT system, and of course, again, from digitalization, for going to a digital world and sort of IoT, we could obviously digitalize the manual, so there's no paperwork on the shop floor. okay, as well. It's all, you know, electronically manual. I'll hand you over to Fergus now for a little bit, and he'll talk to us a little bit about the technical basics of how, you know, what frequency we use and how RTLS works. So Fergus.
Thanks very much. Yeah, so technical basics. If there we go, I've got the slide up there. So in terms of RTLS as a whole, think of the technology essentially like your own version of GPS. It essentially works on the same sort of idea of triangulation and time differences, time delays between the receiving and sending of communications. We know where the anchors are, so these the blue boxes in the corners are our anchors or our gateways, and we know where they're positioned. We lay them out in specific measured positions all over our factory, and then the transponders output a signal which each of those anchors or gateways receives, and the time difference is used to calculate the position. That's in essence how it works. But we do actually have two different solutions, two different ways that we can do that. So we've got TDOA, which is time difference on arrival, and TWR, so two-way ranging. Now, essentially there's TDOA is less accurate, but we can have far more transponders, so we can have up to 120, whereas with TWR, that's per radio cell, that is. Whereas TWR, we can have up to 30, but that's where we can get a much more accurate measurement of our transponder's position. But a key thing to remember with this is not every solution needs down to 30 centimeters of accuracy, and not every solution needs that level of accuracy in every location. So we don't even have to say, okay, we want our entire factory to be 30 centimeters, 1 meter, 2 meters, whatever. You can have different areas where that accuracy is greater or lesser, depending on what you need to know. So let's take, for example, a forklift. If a forklift's placing something on a shelf, maybe they would want down to 30 centimeter accuracy, so you know exactly where it's been put on the shelf. But perhaps when that's being, whatever's being put on the shelf, when that's being driven down to another area of the factory, we don't need to know down to 30 centimeters. We can do within 5 meters, for example, just anywhere on the road. We know it's in transit. That's all we need to know. And these two options do give you flexibility in that. We've got different bandwidths as well. So we've got 2.4 gigahertz on the left, which, as you can see, distance indoor 230 foot, outdoor 330 foot, ultra wideband on the right, indoor 100 foot, less range on that one. But again, that one's more about having sort of high volume number of tags, much simpler communication. For reference, the TDOA is on average one radio package per position calculation, and the TWR is 20. So it's a significant amount more communications. Essentially, the transponder outputs a signal, and the gateways respond back, and then it works out which ones are the closest with TWR to get the most accurate position, whereas TDOA is simply just, it outputs a signal, all of the gateways that see it log the time that it was received at, and then locating manager will calculate roughly where that tag should be. Okay, if you want to go on to the next slide, Lee, we'll have a little look at a factory overview. So you can see here that we've got an example of a factory floor layout with some gateways, which are the red squares. And they're not evenly spaced in this position, which might look a little bit odd, and they're only in one area of the factory. But actually, this is a perfect example of where we're talking about having different regions of different resolution. So if you could go to the next slide, Lee, we should get an overlay on top of that.
Yep.
There we go. Yep. So you can see there in the orange area, we've got down to 12 inches, so down to our very high accuracy in perhaps some racking where we want to know exactly which shelf we've put a product or a carton of products on or something like that. And then you've got all the way up to the pink area. So right out at the edges of the factory, we don't need to know exactly where those cartons are going to. We just need to know if we need something from those cartons, roughly where they've gone within the factory. And everything in between, of course. And again, it's all about the scalability with RTLS. You know, you don't have to have an entire factory done in one go. You don't have to have a blanket setup for the entire factory. You can have different sort of setups of gateways in different areas, different resolutions, depending on what application you're doing, and different transponders indeed. If you wanted to have the e-papers on the front of your tote bins or something like that, and perhaps some OEM helmets tracking lone workers who might be out on another part of the site somewhere. If you go on to the next one, Lee, as well. Here's another example of how we can change the way that we use it slightly, is presence mode. So this is essentially working just like a ping, almost like RFID. So we've essentially just got a field, and we're just saying we can see something within that field. So this gateway in question, if something enters there, it'll say, I can see a tag within my field. And that might be enough, like we were saying, if we have lone workers, for example, who are out on a large scale site, getting down to 30 centimeters of accuracy, not necessarily required, but we just need to know roughly where that they are. So say, for example, they pull a panic cord or something like that, we know where they've come from, or if they call us, for example, because they've slipped, we can straight away see where they are, what region they're in, and get out there to go and help them. If you go on to the next one, Lee, that gives us a representation of how much coverage, for example, you could have there in the presence mode. And another example, if you go on to the next one, is if you imagine a high bay warehouse, so you've got racking going from floor to ceiling in a warehouse, transmitting through metallic racking, especially if it's filled with lots of products that contain metals, for example, is a tricky thing to do because obviously metal conducts things like radio frequency. But we don't necessarily actually need to look through the racking. If we've got a high bay warehouse with high bay warehouse forklifts or a fixed system, a carrier system, we just need to know sort of X, Y. We don't need X, Y, and Z. So we can just have a situation like we have here with the gateways at either end, and we can do this sort of 2D locating pathway. We know that we're in this fixed sort of window where the high bay warehouse forklifts will be. So we don't need anything more complicated than that. We can set it up like this if we need to. So that, like I say, it really is all about stressing that scalability. There's lots of different options for how you can utilize RTLS. And with all SIMATIC ident, it's another vehicle for data. And once you've got that data, there's all sorts you could do with it. As we were talking about before with social distancing, if you had already a lone worker system in place where you've got helmet tracking, suddenly someone goes off ill, you can look back, if you've got the software for it, look back through your system. Has that person been in contact with other workers for, I don't know, greater than 15 minutes in the last week or so, and are those workers then likely to get ill as well? All that kind of, those possibilities are open to you once you've got that data. I think that's the end of that bit, and Lee's going to go on now and tell us a little bit how we might go about starting a project.
Okay, can you hear me, Fergus? Because this is where it went wrong this morning.
Yes, we can.
Okay, okay, no problem. So yeah, the final couple of slides is how we sort of initialize and we sort of get involved with a particular customer. So it's worth pointing out is what in RTLS is what services that we probably don't provide or what we would expect to be provided by a customer. And this is the like of, the server, for instance. We'd expect the customer to provide the server for us to obviously load the locating manager onto. With RTLS, obviously remote access is pretty critical for us to make what we call our commissioning and our sort of fine tuning to the system when it comes to checking the accuracy and it's also obviously mounting of the tags itself. So again, that's something that the customer would do to mount the tags. What we do as Siemens for you is we have our on-site sort of site survey that would allow us to give you a detailed plan, what we call a device plan of where the devices would need to be positioned. A full in-depth electrical manual sort of for whether it be the engineering team or whether it be a third-party electrical services company that can go and install the gateways and the network cabling. And then that allows us to come back and accept off the infrastructure. We'll come back, make sure it's installed correctly. We can supervise the measurement. We have to measure the antennas when they've actually been installed, and then obviously we can optimize the system, give you documentation and training, and then obviously final acceptance. So that's obviously, it's just worth pointing out what we do as Siemens and what we'd expect a customer or one of our solution partners to deliver for us. And that pretty much sums up the RTLS stuff as a quick overview, technical overview for you. So there you go. You've got my contact details there. You've got Fergus's contact details there, just in case you wanna get in contact and drop us emails, or you want any more information. Then we're more than happy to do that. Or if you've got any pressing questions, I'm sure me and Fergus will try our best to answer them for you now. If anyone has any questions for us in the last 5 minutes or so.